Hi, this is Bukya Krishna, roll number 20951A2130, branch Aeronautical Engineering, topic Basics of Heat Transfer. First, we want to discuss about heat and thermodynamics. Heat, the form of energy that can be transferred from one system to another as a result of temperature difference. Thermodynamics is concerned with the amount of heat transfer as a system undergoes a process from one equilibrium state to another. Heat transfer deals with the determination of rates of such energy transfers as well as variation of temperature. The transfer of energy as heat is always from the higher temperature medium to the lower temperature one. Heat transfer stops when the two mediums reach the same temperature. Heat can be transferred in three different modes: conduction, convection, and radiation. First, what is heat transfer? Heat energy always moves from a warmer substance to a cooler substance. So here are the two diagrams, one is hotter and one is colder. Here are the directions shown in the figure that moves from hotter bodies to colder bodies. Heat will continue to move until both substances at the same temperature. The greater the difference in the temperature between the substances, the faster the heat will transfer. There are three types of heat transfer as we discussed above: conduction, convection, and radiation. Examples and anti-examples. You touch a black car in the summer and the heat from the car transfers into your hand. Then you feel somewhat hot. And you feel the cold of a winter day because in the cold air transfers into you. And a breeze makes you feel cooler because the wind transfers heat away from the body. And your coke in the cooler gets cold because the cold from the ice moves into the coke. So first we will discuss about conduction. The transfer of energy from the more energetic particles of a substance to the adjacent less energetic ones as a result of interactions between the particles. In gases and liquids, conduction is due to collisions and diffusion of the molecules during their random motion. In solids, it is due to the combination of vibrations, the molecules in a lattice, and the energy transport by free electrons. The rate of heat conduction through a plane layer is proportional to the temperature difference across the layer and the heat transfer area, but is inversely proportional to the thickness of the layer. Conduction. The heat transfer by conduction is the transfer of heat through direct contact. Here you can see the cooler body and the heater body are in contact. Molecules transfer energy to the molecules next to them. So this is the diagram how the metal conducts heat from the cup of the warm water to the cup of cool water. So one is warm water and another is cool water. This is the setup how we done. Next, the radiation. The energy emitted by matter in the form of electromagnetic waves or photons as a result of the changes in the electronic configurations of the atoms or molecules. Unlike conduction and convection, the transfer of heat by radiation does not require the presence of an intervening medium. In fact, heat transfer by radiation is fastest at the speed of light and it suffers no attenuation in a vacuum. This is how the energy of sun reaches the earth. In heat transfer studies, we are interested in thermal radiation, which is a form of radiation emitted by bodies because of their temperature. All bodies at a temperature above absolute zero emit thermal radiation. Radiation is a volumetric phenomenon, and all solids, liquids, and gases emit, absorb, or transmit radiation to varying degrees. However, radiation is usually considered to be a surface phenomenon for solids. Radiation. Heat transfer by radiation is a transfer of heat through electromagnetic waves, as we discussed above in the previous slide. There is no direct contact between the substances. In conduction, there is a direct contact, and heat from the sun radiates through empty space to the earth. In this, we can configure that there is no vacuum present in the radiation. Next, convection. The mode of energy transfer between a solid surface and the adjacent liquid or gas, that is in motion, and it involves the combined effects of conduction and fluid motion. The faster the fluid motion, the greater the convection heat transfer. In the absence of any bulk fluid motion, heat transfer between a solid surface and the adjacent fluid is by pure conduction. The convection. Heat transfer by convection is transfer of heat through the fluid, liquid or gases, movement of currents as we discussed in the previous slide. And warm fluids rise, cool down, sink and then are warmed again. Here is a diagram of the convection. The radiator warms the room by warming the air around it. Then the warm air transfers heat to the rest of the room through convection. So the warm air rising to the cold windows and cool air falling to the hot radiator. As air above the road warms up, it rises and is replaced by cooler air, warming convection current. So these are the applications of convection, right? And this picture illustrates all three types of heat transfers. That is conduction, the direct contact, radiation to the non in contact, and convection to the moving particles, as we discussed in the previous slides of conduction, convection, and radiations. This picture illustrates all the three types. Okay, thank you. This is presented by Bukya Krishna 20951A2130. Thank you.